All right, last two, here we go. Piecewise defined functions, mad easy. The limit's going to 1, and it's broken up at 1, so we're going to have to check from the left and right. So limit as x goes to 1 from the left. If I have values to the left that's less than 1, that's going to be the top function, the top piece of that function. So we have 3x minus 1, we can plug it in. 3 times 1 minus 1 gives us 2. Limit from the right. Value is greater than 1, so you're going to get 3x squared. And we can just plug that in as well. And that's going to give you 3. The left and right hand side limits don't match, so the limit as x approaches 1 of the function f of x is equal to, does not exist. All right, and then last up, this is one of the most important limits in all of calculus, okay? We're just going to compute it like we've been doing. We're going to notice at the end that the answer is not an actual number. It's going to be a new function. Okay, it's going to be a function of x. This is what we call a derivative. This is one of the most important things in all of calc. All right, so you're going to see this limit over and over and over. All right, so pretty basic. It's just not going to work quite the same as the other ones. All right, so first thing to notice is that h is going to 0. Okay, h is going to 0. However, we have x's and h's inside of this limit. Okay, we'll talk about why that's the case very, very soon. Okay, so what we're going to have to do is plug in 0 and see what happens. If you do that, we're going to get 0 over 0, so it's an indeterminate form, which means we're going to have to do some algebra to cancel out that h in the bottom. Okay, so I'm going to FOIL. Let me do it down here, and then I'll just erase it. So I have x plus h quantity squared. So if you know what that is off the top of your head, that's great. If not, we can just FOIL. So we end up with x squared plus xh plus xh plus h squared for a total of x squared plus 2xh plus h squared. All right, so we're going to say the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. And let me get rid of this because we just FOILed. All right, so now let's clean it up a little bit. So we have this here, this x squared, and this negative x squared will go away. So now we have the limit as h approaches 0 of 2xh plus h squared over h. Now if you notice in the numerator, I can factor out an h. So if we pull out an h, we'd end up with 2x plus h all over h. Those will go away. And now we can plug in 0, but we're only going to plug it in for h, so we're going to leave the x alone. So this equals the limit, actually no, it doesn't equal the limit because now we're going to plug it in. So it's going to equal 2x plus 0 for a total of 2x. Okay, this is going to be very, very important. So as the year goes on, we'll put this limit in context and we'll explain why we're adding h and what that means and why we ended up with 2x. All right, so more information on this as we go. All right, I'll see you guys tomorrow.